to do a brain dump on seasons, the reasons for seasons. So we're going to start with the sun, and we're going to draw 4 models of the earth. These models are going to represent our 4 seasons: winter, spring, summer, and fall. First, I would like to point out that the Earth does a counterclockwise revolution around the sun. Counterclockwise is the opposite direction the arms of a clock go. It takes Earth 365 and a quarter days to do a revolution or orbit around the sun. Next, we want to draw the imaginary axis through each of our models. We're going to have that imaginary axis all point in the same direction. If it helps you make a northern star, you can do that as well. So your axes are pointing in the same direction. That's our tilt of 23.5 degrees. Because of that tilt, that's one of the reasons for seasons. It's because of the tilt and Earth's revolution around the sun are the 2 reasons for seasons. Next, we're going to draw our imaginary equator, which is going to divide our northern and southern hemispheres. So above the equator is your northern hemisphere, below the equator is the southern hemisphere. When the hemisphere is tilting away from the sun, the hemisphere is experiencing winter. When the hemisphere is tilted towards the sun, they're experiencing summer. Winter means indirect rays of the sunlight, so you're having shorter days and cooler temperatures. Summer means you're getting more direct rays and temperatures are higher and the hours of daylight are more. Your northern hemisphere is opposite of your southern hemisphere always. Now, Earth is going to do a counterclockwise revolution around the sun, but I'm going to skip these 2 seasons because I can't tell whether that imaginary axis is tilted toward or away from the sun. Because in those 2 positions, you have equal hours of daylight and equal hours of darkness. So you're in equinoxes. That's either your spring or fall. So I'm going to determine the seasons in this position over here. So here, my northern hemisphere is tilted towards the sun. So my northern hemisphere is experiencing summer. My southern hemisphere is tilted away, so it's winter. Now I'm not going to write that because I'm only going to focus on the northern hemisphere because I know the southern hemisphere is just the opposite. So next, what I'd like to do is to determine the season that's in between winter and summer. If I'm going counterclockwise, I have to say to myself, okay, it's winter, then I have a season, then it's summer. So after winter, we have what season? Then it's summer. So that would be spring. So your northern hemisphere would be spring. Your southern hemisphere would just be opposite, the fall. So if this is winter, spring, summer, this must be fall over here in your northern hemisphere. Autumn is another name for fall. Okay, so your reason for seasons, the tilt, and as Earth does the revolution around the sun. So that was a brain dump for seasons, and I'm going to flip my paper, and now we're going to do a brain dump for our moon phases. So we're going to SNEF our moon phases. SNEF stands for the sun. Then I have a new moon. Then I have the earth. Then I have a full moon. Sun, new moon. A new moon, when you're on Earth and you look up at the moon, you don't see any illumination. Okay, no light from the sun. It's dark because the side of the moon that's being illuminated is the back side. So you see no illumination. Here's Earth, and then you have your full moon. Your moon is going to do a counterclockwise revolution around the earth. And to go from a new moon to a full moon, we have to wax in illumination. So we say this is waxing. Okay, and then from a full moon to a new moon, we're going to lose that illumination, and we call that waning. I like to draw my 4 major phases of my moon first. So if I'm in the waxing period here, waxing means I have light on the right hand side of the moon. So I'm going to shade in this side. This would be my first quarter. Okay, and then I wax, I increase in light on the right until I'm full. And then when I wane, I lose the light on the right. So I'm going to shade that in, shading in the right side of my moon. This moon is called your third quarter. So I'm just going to write third quarter. Okay. And to go from one major phase to the next, it takes 7 days. One major phase to the next, 7 days. One major phase to the next, 7 days. One major phase to the next, 7 days. 7 plus 7 is 14, plus 7 more is 21, plus 7 more is 28. It takes the moon approximately 1 month to do a revolution or an orbit around the Earth. Okay, let's do our in-between phases. There are 4. Okay, so if I'm a new moon and I gradually increase light on the right, I'm a crescent shape. So I'm going to shade in this side. I need to have light on the right. So this is a waxing crescent. It's about 25% illumination. Then I'm going to grow more light on the right. I'm about 50. Then I'm going to grow more than 50, and I'm about 75. So that's going to be called a waxing gibbous. So I've waxed in light. So I've increased light on the right-hand side. I'm full. Now after a full moon, you lose that light on the right gradually. So I just lose a little light on the right. So I'm called a waning gibbous. Then I lose a little more light on the right. I'm my third quarter. It's about 50% loss. Then I'm going to lose more than 50. And so here I'm a waning crescent. And then I lose more and I'm back at that new moon phase. So waxing, I have light on the right, and then I wane. I lose that light on the right. I hope that was helpful.